So in this video, we're going to talk about antiderivative formula. So when you think about antiderivative, this is quite similar to derivative. It's just the opposite, the reverse function. Earlier, we talked about, hey, if I ask you to find fx equals to x squared, how do you find the derivative? So it's going to be f prime of x, which is 2x. You got that, right? So now it just from the derivative, I need to find the original function. So the process is called antiderivative. So here is the formula. So the derivative rule is building the blocks. So from the constant multiplied rule, so if you're taking the derivative k times f, so this is equal to k times the derivative of f. So you're just taking the k outside of the derivative and just take the derivative of the function. And then for the sum or subtraction, the differences rule is the same. So if I want to take the derivative of two functions, f plus g, this is equals to f prime of g prime, plus or minus. You do the same thing for the subtraction. And for the power rule, we have the derivative at x to the n. When you take the derivative, this is equal to what? You put the n in front, and then x is equal to n minus 1 power. And then for some special cases, such as you take just the derivative of x, so this is going to equal to 1 because that's the power equals to 1. Or if you take a derivative of a constant function, this is going to equal to 0, such as you take derivative of 4, so you will get a 0. And then there's some exponential rules. Which means you take in derivative at e to the x is going to equals to itself. And then you take derivative of a times a to the x. This is equals to ln of a, the natural log to the a, times ax. And the last one is the natural logarithm derivative. Rule is if you take derivative of ln of x, this is equal to 1 over x. So this is the formula that you need to remember, because when we do it antiderivative, you need to do it from the other direction, from the right to the left. Okay, so for antiderivative, what is the constant rule look like? I'm going to write it next to it so you can compare these two. So for antiderivative, remember our notation is going to be an integral k of x dx. So the antiderivative is, you can also pull the k out and just do the antiderivative of ks. So remember, it's from the left to the right. From the right to the left. Okay, so for the sum and differences rule is the same. If I want to take the antiderivative f of x plus g of x dx plus or minus, so this is going to equals to the antiderivative. You do it separately. All right, so for the power rule, so now I want to take the antiderivative of x to the n dx. So what happened in here? If you think about it, if you want to do the derivative of fn, you need to pull the n in front and then subtract 1. Now we're doing the opposite. So that means I need to have, and since the power is n plus 1, because this is the antiderivative. You don't want to subtract 1, you want to add 1. And then instead of multiplied n in front, you want to divide n minus 1. So that's the antiderivative. Also, you need to plus a constant c. So for special cases, such as you have a constant, you want to do the antiderivative. This is going to equal to k times x, and then plus a constant. Okay, so for the exponential rule, the antiderivative of e to the x, is going to be the same, but you need to plus a constant c. And then if I want to do the antiderivative a to the x dx, this is something that you need to remember. It's going to be equal to a to the x power over ln to the a, and then plus a constant c. Okay, the last one is if I want to get the antiderivative of 1 over x at ds, or sometimes they can written as x to the negative 1 power at dx. This is going to equals to ln x plus c. Okay, so with this rule, let's try to do some examples. For example, I want you to find the antiderivative of 3x to the 7 minus 15 square root of x plus 14x squared. Well, if it's finding the antiderivative, we already learned the antiderivative notation is going to be this one. And then I want to write all the x into an exponential form, because that can help me to do the antiderivative by, it's easier for me to apply it on all of these formula. Okay, so when I would write this into exponential form, this is going to be 15 times 1/2 at 14 times x to the negative 2 power at dx. Okay, so we know that when we do the antiderivative by the sum and differences rule, I can just derivative each of these terms. Okay, so now let's do the antiderivative of 3x to the 7th. So for constant, we can just leave it as is. So for the 7, you need to add 1, which gives you an 8, and then divide it by 8. Why is that? Because you think about it. So the 3 we don't need to think about too much. So let's keep the 3 to the 8 to the 8th. When we get the derivative of this number, what happens? Well, you will have 3/8, and then the 8 you put in front, and then you have x a minus 1 power, which gives you 3/8, a and a they cancel, and you will have 3 times x to the 7th power, which is what we are trying to do for the antiderivative. Okay, so now keep going. We have negative 15x to the 1 over x. So that means these are the 15 times x 1/2 plus 1 over 1/2 plus 1, whatever that is, which is 3/2. We simplify it later. And then add 14 times x minus 2 plus 1, which is equal to -1. So that means I want divided by -1. So when we clean up these a little bit, make it look like nicer, we have 15 divided by 3 equals to 5. 5 times 2, which gives us a 10 as to the 3/2 power minus 14x to the -1 power. Do we miss anything? Yes. Don't forget add the constant c, because when you take, one way to check this is when you take a derivative of this function, you will get here. So that means, oh, you do the antiderivative correct. So now let's do another example. I have e to the x at 12 minus 16x. I want you to find the antiderivative. Again, I can find the first one, e to the x, that's easy. And then plus 12x. Because if the antiderivative is a constant, that means the original function is going to be just multiply the variable. And then minus, well, this one probably is harder. So you can think about 1 over x. What will be the antiderivative of 1 over x? It's going to be ln absolute value of x. Don't forget to plus the constant c. Okay, another application for the problem is I can say, hey, found fx so that f prime of x, the first derivative, is equal to us, and then f of 0 equals to 10. Well, let's try to find the fx first by doing the antiderivative of that. So the antiderivative of f prime of x is going to equal to e to the x ds, which is e to the x plus a constant. So that will be our original function. If you take antiderivative of the function, you will get a derivative of the original function. And we also know that f of 0 equals to 10. That means e to the 0 plus c equals to 10. So that means what? E to the 0 equals to 1. So c is equals to 9. So that means our original function is going to be e to the x plus 9. So that when you take the derivative, this is equal to e to the x. Let's check it. Well, check. F prime of x equals to e to the x derivative plus 9 derivative, right? So this is e to the s, 9 derivative, a constant, equals to 0. So this is correct. And then f of 0 equals to e to the 0 plus 9, which is 1 plus 9 equals to 10. So also satisfy the second condition. So that means this is what we want. So let's recall the fundamental theorem of calculus. So the fundamental theorem of calculus is the integral from a to b f prime of x at ds is going to equals to the original function b minus f of a. Now let's use these, try to evaluate a function. Okay, so let's evaluate from 1 to 3 d of x. Okay, so there are two ways to do it. You can either use a graph or use our fundamental theorem of calculus. Let's use the fundamental theorem of calculus. So by the fundamental theorem of calculus, I know that the integral from 1 to 3 x dx is equals to f of 3 minus f of 1. So that means I need to find the original function. Well, the derivative from 1 to 3x dx, so the fx equals to what? Well, we know that it's equal to 1/2 x squared plus a constant c. But if they tell you a specific number, you don't need to plus c, because when you substitute the number into it, you will find out that the c will be cancelled out. Here, I'm going to show you. So the original function is 1/2 x squared plus c. So that means f of 3 equals to 1/2 3 squared plus c minus 1/2 1 squared plus c. So this is some place that we need to put a parenthesis, because you're trying to subtract the whole number instead of just 1/2 times 1. Okay, so when we move the parentheses, I will have minus c. So look, these two constants will cancel out by the subtraction. Okay, so I have 9/2 minus 1/2, which is gives me 4. So that will be the value of this function equals to 4. So what would be the second method? Well, the second method is going to be you graph it. Remember? So this means the area underneath the graph. This is the graph y equals to x, which here, and then the area bounded from 1 to 3 and the x-axis. If we can find the shady area, that would be the answer for these questions. So how do we find the area? If you take a look at this area, I can use a big triangle to subtract a small triangle so that I will get the area. So the big triangle is equal to 1/2 times this is equal to what? Well, we know that this point is at y equals to x, so this means this is 3, 3. So that means the height is equal to 3 when the base equals to 3. Minus this point, 1, 1. So 1/2, 1 times 1, so which is 9/2 minus 1/2, which is 4. So the shady area is equal to 4. All right, so now what if I can graph this? Now I can graph this because this is a nice constant change. What if I have something curved, such as I want you to find the area of the graph of y equals to 3x squared from x equals to 1 to x equals to 2. So now we can just use the fundamental theorem of calculus. So the integral from 1 to 2, 3x squared at dx is going to equal to the original function. When we do the original function, this is s to the cube plus c. Again, I talked about that, I just showed earlier. In this case, if it's an exact number, we don't need to worry about the constant that much. If they just want you to find the original function, then you need to add the constant c at the end. So this notation means the original function from 1 to 3. So that gives me what? 3 to the cubed function minus 1 to the cubed function, which is 9 minus 8 minus 1. Oh, this is from 2 to 3, sorry. So this is 8 minus 1, which is 7. So now take a look. A robot being programmed so that when it starts to move, the velocity after t second will be 3t squared feet per second. How far will the robot travel during the first 4 seconds of the movement? Well, distance is equal to what? Distance equals to the speed times the time. So that means we're finding the area bounded by 3t squared, and then x equals to 0, x equals to 4, and the x-axis. So basically we're finding the integral, right? So that means how far will the robot travel during the first 4 seconds? So that means we're finding the integral from 0 to 4 3t squared at dt. Well, when we simplify it, I have antiderivative t to the cubed function from 0 to 4. So I have 4 to the cubed minus 0 to the cubed power. So I will have 64 feet. That's how much the robot traveled from the first 4 seconds. And now they ask you how far will the robot travel during the next 4 seconds. So that means your integrals are starting from 4 to 8, 3t squared dt. So that means the antiderivative is going to be equal to t to the cubic power from 4 to 8. So I have 8 to the cubic minus 4 to the cubic power, which is equal to 412 minus 64, which is 448 feet. So that means in the next 4 seconds, the robot travels 448 feet. So here is the next questions. So suppose after t minutes, putting 1,000 bacteria on a Petri plate, the rate of growth of the population is 6t the bacteria per minute. How many new bacteria are added to the population during the first 7 minutes? Well, the number of the new material is the area under the rate of growth and the one derivative of 6t, right? So that means we are finding the area from 0 to 7 at 6t dt, which is equals to, when we do the antiderivative, this is equals to 2 to the t squared from 0 to 7. When we simplify, I have a t to the t squared, 0 to 7, which is 3 times 7 squared. So that is 147. When you minus everything multiplied 0 equals to 0. So we don't need to worry about the 0 in here. So that means that's how many new material added after 7 minutes. So B is asking you, hey, what's the total population after 7 minutes? Well, the new population should equals to the original population, which is 1,000 at the new material, which is 147. So that means after 7 minutes, the total material is going to be 1,147. So, okay, so this may be our last example. A company determined their marginal cost of the production in dollars per item is marginal cost function equals to 4 over square root of x plus 2 when producing x thousands of items. Find the cost of increasing production from 4,000 items to 5,000 items. So remember that the marginal cost is the rate of change of cost, right? So we know that if you want to find the cost from 4,000 to 5,000, so that means you're looking for from 4,000 items to 5,000 items at this area bounded by this function, which when we're trying to find the antiderivative, I can rewrite this as, let me rewrite this. The integral from 4 to 5 x times 4 times x to the negative 1/2 power plus 2 at dx. And then when we find in the antiderivative, I have 4 times x and then negative 1/2. I need to plus 1, so that gives me 1/2. And then I need to divide it by 1/2 plus 2 times x plus c. We talked about that. We don't need to worry about c when we calculate the accurate function. So this whole part you need to subtract in from 5 to 4. Well, let's simplify it. So to make it look nicer, so this should be 8 times square root of x plus 2x from 4,000 to 5,000. So I have square root of 5 plus 2 times 5 subtract 8 times square root of 4 plus 2 times 4. Okay, So something that don't forget, you are subtracting the whole function. You are doing f of 5 minus f of 4. So that means you're not just subtracting 8 times square root of 4. You are subtracting 8 times square root of 4 plus 2 times 4. So you can use a calculator to calculate this one. So this is approximately $3 and 3.889. So be careful, the unit is $1,000. So that means it will cost $3,889 to increase the production from 4,000 to 5,000 items. Okay, so that's it for the antiderivative rule. See you next time.